Welcome to another episode of Air Power Live. Today, the importance of ground in finishing. Let's talk about this in a grander spectrum here. When we talk about a finishing booth or a finishing operation, let's touch on things. What in a liquid or a powder booth needs to be grounded? So it's pretty obvious. Everybody talks about grounding the part. So we're looking at part connection all the way back, okay? And we know that that's got to be grounded. We know that typically the gun has to be grounded. The controller has to be grounded. But let's talk about those other things. I know you were touching on a few of them there, but let's touch on the different things that must be grounded for a smooth operation.
Right. As a rule, we're talking about solvent-based coatings here. So keep that in mind. Not necessarily water-based for the moment for this ground. This is attached. This is a great grounding clamp. Sharp points.
A lot of pressure.
A lot of tension here from the spring, right? You cannot use a plastic bucket and expect it to be groundable. It is not. Don't use them in your finishing operation. Only use a metal bucket. If you use a liner, make sure that the liner is static dissipating also. Most of the white ones are not necessarily static dissipating. The pink ones always are. Ground it to the bail if you want, the handle, or ground it to here, right? If you're spraying out of a pressure pot, ground your pressure pot. You've got to have it grounded. If you're spraying from a pump, you ground the pump. You ground those sources. If we start the ground here, then we don't have any problem as the way we go out, right? So when we ground this,
we're using this.
Use whatever clamp that you want to use. Make sure it's a good one in stranded wire and with a good force. Anything that would be in the booth, say I had this in my booth and I had it covered up and I wanted to flush inside of it and it stays in here, it needs to be grounded too, right? You have to have it grounded too. Any metal object, like the conveyor up there, any metal object that's inside the booth must be grounded, because if you're spraying electrostatically, it will pick up a charge. If you don't ground it, it will become a capacitor, and a capacitor stores energy, and when you come to touch it, it will release that energy and shock you and create a spark that might be enough to ignite a flame. So watch that.
Yeah, substrates can also take the charge when they're hanging from the conveyor rack or the rack or the rolling rack. So we want to make sure that we are grounding those so that we don't have issues. Let's talk about hooks. Well, first of all, I want to make something really clear here. When you're troubleshooting your coating operation, you're having rejects because you're not getting enough paint into an area. Your recessed areas of your parts that you know have Faraday issues, hard to reach geometries, and the paint's not going there. There's a few issues to look at. One is your approach to the part, the actual operator and how they're approaching the technique. But and that's another thing altogether. That's a lot of training. But the science behind that with the Faraday cage and ground is marries so tightly to the fact that unless you have that part grounded perfectly, you're not going to be able to easily get that paint into that Faraday area. The Faraday area, even if it's grounded, is still it still can be difficult.
The Faraday phenomenon is there no matter how good the ground, but it allows you to paint better if it is well grounded, the substrate.
So when I was in the paint market selling powder coating and working in the powder market troubleshooting, the first thing that I did is I would trace ground all the way back to the original source. I would find the ground rod that was buried in the ground with that much, on top, exposed afterwards. People will say, how far do we need to drive the ground rod into the ground? As far as you can get it. And if you can get it in with this much on the top, just enough to get a hook onto or a clamp onto, you've done a great job. And we will talk about that. So you go from there to the wire that leaves there, the connector and the wire that leaves there that goes to the rack that's holding the part. If that clamp at that time, whatever style clamp it is clamping onto the substrate or onto the rack, and the rack has powder buildup on it, you know, like this, and you're clamping there, you've just killed your ground right there. You've got nothing. If it's in an area like this where there's a little bit of paint, maybe it's questionable. But then you've got to follow it from that point. You've got to go look at where the rack and the hook connect. So the rack rod or the top or like this, where that connection is, and then you've got to look at this connection to the actual part substrate that's hanging. So everywhere that you go down that, path.
Right. The conveyor is the start. That's grounded separately. Then the hook, right? If you have load bars that have multiple parts on it, then that's a conveyorized, if you will, system that has an opportunity to build up paint on it as well, because it's grounded and it's attracted to it, the paint is. Oftentimes you have multiple hooks. So if this hook and this hook are connected, then that's another ground point. When we hang our parts off of it, right, then here's our final ground. So chase it back at each point. Each point has a resistance there that could be there that's causing you ground issues. If you hear or see arcing, tick, 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 pop, 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 you have a bad ground. We have charged the part with electrostatic coating process. We don't mean to charge the part. That's not what we want to do, but we put charged particles on it. It's in the field. We do charge it, but that's okay because we're going to bleed it straight to ground, right? We're going to take it and put it right into the earth. That's an earth ground. It's going to take the charge from this and put it here where it belongs, and not this become a capacitor to shock you later. So each hook point is paramount that it's clean. These are diamond shaped hooks right here. Better than round hooks. A round hook doesn't stay clean as well. The sharp edge on the diamond hooks allows that to dig into the part and keep a cleaner surface.
And when it comes to hooks, a lot of it has to do with proper maintenance. If you're running an operation and you're using hooks constantly in your operation, you've got to look at a way for preventative maintenance to be instilled into this, to where we're able to take hooks off the line, burn them off, clean them, blast them, whatever that is.
Chemical strip, fluidized bed, sand, hot sand.
Yep.
There's multiple methods, but the important thing is get it clean and do it on a proper rotation. Average rule of thumb, 4 passes through the system, yank it off, clean it again.
But that's every bit of that decision is based on how much coating is getting on your hooks in that process. I wanted to invite you to watch more Air Power videos. Give us a call anytime at 800-334-1001. You could reach us on the internet at airpower-usa.com. And what social media channels are we on, Eddie?
All of them. LinkedIn, Facebook, Twitter, YouTube, Instagram. And the best way to get help from us is call us. We'll come out, visit you, and we'll make sure that you got a good ground.